Hello guys, welcome back to my YouTube channel. My name is Aditya, studying in Sri Venkateswara College of Engineering in the section Artificial Intelligence. Today I'm going to explain about the topic binomial distribution in the subject Mathematics for CSE stream BCS 301. Introduction to binomial distribution. The binomial distribution is a discrete probability distribution. It models the number of successes in a fixed number of independent Bernoulli trails. Each trail has two possible outcomes, success or failure. So each of the trail has any two of the outcomes, one is success or either of failure. The next one is characteristics of binomial distribution. The binomial distribution is defined around by two parameters, the number of trails and the number of probability. So the number of trails is defined by n, and the number of the probability of success is defined by p. The trials must be independent of each other for the distribution to apply. The binomial distribution can take on integer values from 0 to 1. So the binomial distribution may vary from 0 to n. Any number between 0 to n, but not negative numbers, only positive numbers. The binomial formula. The probability of exactly k successes in n trial is given by the formula p of x is equals to k is equals to c of n comma k. P to the power of k 1 minus p to the power of n minus k. So when p of x is equals to k, that will be c of n comma k. When if p of k, what is the value of k over here should be the same value over here also. So we have here p of in the diagram we have p of x is equals to n by x into p of x into q to the power of n minus x. That can be written as n by n minus x factorial into x factorial into p to the power of x into q to the power of n minus x. So you know the formula of ncx, right? That is the same applied over here, but the c is not written here. That's the difference, where n is the number of trials or the number of being sampled, and x is the number of successes desired, and p would be the probability of getting a success in one trial, and q would be 1 minus p. So as you know, p is the probability of getting something and q is the probability of not getting something. So if you want to know the probability of not getting something, we should subtract p 1 minus p. So the probability of anything happening in total would be 1. So if anything is happening like for example, this torch should turn on, means the probability of on the torch would be 0.5. See, the probability of not turning on the torch would be 1 minus 0.5. So that's why q is equals to 1 minus p, the probability of getting false. Next we have mean and variance. The mean means expected value of a binomial distribution is calculated as mu is equals to n. The second bullet, the variance of distribution is given by phi square is equals to n. Formulas of variance would be given by, for grouped and ungrouped and population and sample, phi square is equals to summation of x minus x dash whole square divided by n. For population, for ungrouped sample, it would be phi square is equals to summation of x minus x dash whole square divided by n minus 1. So for population and sample, the difference is nothing but there it would be n and here it would be n minus 1. In group population, we have phi square is equals to summation of f of x minus x square divided by n. So the difference between grouped and ungrouped population would be f of x minus x dash square, and in ungrouped it will be just x minus x square x dash whole square. So in group sample, it would be phi square is equals to summation of f of x minus x dash whole square divided by n minus 1. So it's the same, n and n minus 1 is the difference over here. So in the next slide we have conditions for binomial distribution. There are 4 key conditions that must be met for a binomial distribution to be binomial. The trials must be independent and the number of trials must be fixed in advance. So the trial must be independent, and the second one will be the number of trials must be fixed in advance. Means first only we should fix the number of trials. The probability of success must remain constant across trials. So the probability of success should not change in any point of the trial. Binomial distribution formula: P of x is equals to NCX P of x. That's the same thing over here, what we read before. Applications of binomial distribution. So where are we going to use this binomial distribution? Binomial distribution is a commonly used in quality control and risk assessment. It is not applicable in scenarios such as surveys, responses, or clinical trials. Businesses use it to model scenarios like product default, defect, or customer satisfaction rates. So in businesses, this binomial distribution is used widely. And it is also used in some surveys also. The next one, we have cumulative distribution function. We can call it as CDF. The cumulative distribution function gives the probability of obtaining at most k successes. It is calculated as if p of x is less than or equal to k, that would be summation of p of x is equals to y for I from 0 to k. So I varies from 0 to k over here in this formula, and x should be less than or equal to k. CDF, that is cumulative distribution function, is useful for determining probabilities across a range of outcomes. Normal approximation. For large n, the binomial distribution can be approximated by a normal distribution. This approximation is valid when both np and n into 1 minus p is greater than 5. So you know np is the probability and n into 1 minus p is the probability of not happening something, are greater than 5. Using normal approximation simplifies calculations for larger sample sizes. Example of binomial distribution. An example indicates flipping a coin 10 times and counting the number of hits. Another example is marketing campaign where a certain percentage of response positively. This example illustrates real world situation where binomial distribution applies. One example would be flipping a coin 10 times and counting the number of heads, and for the number of tails it will be opposite. And another example is marketing campaign where certain percentage responds positively and another would be negatively. This example illustrates real world situations for binomial distribution for easier understanding. So what are the summary and conclusion of this video or the topic? The binomial distribution is a powerful tool for modeling discrete outcomes. So it is a very useful and powerful tool for doing any kind of these calculations, and understanding its characteristics, formula, and applications is essential for statistical analysis. So the understanding binomial distribution is useful for statistical analysis. It provides insights into probabilities in various fields including finance, healthcare, and manufacturing. Feel free to adjust the okay. So that's how much the topic is about. So thank you for watching the video until the end, and please do like my video as it is an important thing for my college video assignment. And if you think my content was useful and it can help you more, you can just subscribe to the channel. And thank you for so much of love. Thank you.